Welcome to today's Software AG webcast titled Adabas Natural on the Cloud, Lift and Shift to Your Cloud of Choice. Today's webcast will be presented by Zvonimir Ivanetich, Senior Architect, Adabas Natural at Software AG. As we move through today's presentation, we invite you to submit any questions that you may have via the Q&A box, which is located on the bottom center of your webcast dashboard. We will address your questions at the end of today's program. In the event that we're not able to answer your question, your submission will be noted, and today's presenter will be back in touch with you as soon as possible. With that, it is now my pleasure to welcome Zvonimir Ivanetich.
Thank you, Will, for this kind introduction. Welcome, everybody on this call, also from my side. So my name is Zvonimir Ivanetich, and as said, I'm a senior architect in the Adabas Natural business unit, supporting our customers on all the innovative topics in the Adabas Natural area. And one topic is the Adabas Natural operation on the cloud. And with this, I'm starting our today's session with the topic Lift and Shift to the Cloud of your choice. And let us first have a look into an overview of the webinar series that I have prepared to you. And there was also a first session, and we started our webinar with the exploration of the journey to the cloud 2 weeks ago. I hope the majority of you have already joined this session. If not, it will be available on demand and stay available. And today we will dig a little bit deeper into the topic about lifting and shifting to the cloud of your choice with some more advanced topics. I will reuse also a couple of slides from the last time, but I will go much faster over them, but they are useful for a recap so that I can build up the full storyline. And I think after today's webinar, you will have a really great understanding how to operate Adabas Natural in the different cloud providers based on virtualization technology. And then my webinar will continue with additional advanced topics that simply today are required to understand, especially the benefits. And here I mean the containerization of applications and also the operation inside of orchestration engines like Kubernetes. And therefore I have prepared additional webinars that will also start in the upcoming weeks. And now I will start with this session, and yeah, you see also a picture of myself. I think I look more or less not much older than on this picture, maybe 10 years, but you can imagine me in this young age. So starting with our today's webinar, let's look at this picture that shows the modern IT platform architecture, where we think all our customers are recommended to operate in this kind of design, where they leverage agile development based on Natural One and the DevOps approach, integrating with source code management system like Git and automating processes with tools like Jenkins. And then on the right-hand side, the modern application and IT architecture, where we see at the bottom the infrastructure that can operate on premises, infrastructure that can operate on private, but especially on public cloud, what is our topic today. And then we have virtualization and isolation that customers can simply leverage depending on their needs. And here we have virtual machines, and we have also containers and Kubernetes technology. And on the top of it, we operate our applications based on Natural and Adabas, but also using additional technologies as Applinks and NTX, as we will see this also today. So starting with the journey, as also seen in the last session, everything starts on Linux. So this is the starting point where customers should operate the applications to run them inside of cloud. This as a small recap here, and you see on the right-hand side the different pictures and logos of the operating systems on Linux we are currently supporting, Red Hat, SUSE, but also CentOS. And operating on Linux as the starting point is your enabler to easily select the cloud of your choice, like AWS and Azure, to lift and shift your application into these environments. And this is what we will look into today. This is what we will look from an especially infrastructure perspective. But as I already mentioned in the beginning, there are additional webinars that will show us the next step, the next advanced move for going cloud native with your Adabas Natural Application and leveraging containers, APIs, but also microservices. But this, as said, is not the topic for today. We will now look into the journey how to get into the cloud, but starting first as a recap with the system architectures that are widely used on our customer side. As we see here on this illustration, we have widely used data centers currently on premises where customers are operating virtual machines on top of a hypervisor with commodity hardware, multiple servers, and on the back end for the data storage, a storage area network solution with redundant storage. And when it comes to topics about disaster recovery, there is usually a replication to another site, another data center, based on these data requirements. And then looking back at the single architecture, that is the a very common way to operate Adabas Natural Application in virtualized environments. So we saw this the last time, that Adabas Natural Applications are inside a virtual machine with their different components. So you can identify something like an online part, natural online, where you have user interaction from a user interface. You can have services that are accessed by APIs, web applications, mobile devices, and also Adabas as the database residing on the same virtual machine inside this environment and leveraging the capabilities of the infrastructure to operate it in the desired demand. And today, where we will look more deeply, is the distributed architecture. So to look at the whole topic from a more advanced perspective, and here customers have already re-architected applications to increase the scalability and also the availability for these machines. And in this scenario, we have these parts like natural online or natural services running on separate virtual machines, and these virtual machines that are separated, they can scale. As we see on the left-hand side, we can have multiple natural online applications, we can have multiple services on a hypervisor operated. And let's drill down into this in the next slide a little bit more deeply. So this will give you also the understanding to this from other perspectives. So again, we have at the bottom the storage area network, where we have a SAN solution with redundant storages, and then Adabas is running as one virtual machine on top of this. And batch processing can be kept on the same machine, as this is usually from a workload perspective, sometimes critical, so you can keep it close to the database for performance reasons. And then you can operate multiple virtual machines, and in this virtual machine, you can have the online functionality that is exposing a user interface. And here an ideal component is AppLinks. AppLinks as a web emulation software that can directly expose your user interface to an end user. And as we have multiple machines here running on top of this hypervisor, we need a load balancer in front of it. And the load balancer will distribute the workload from multiple end users, web browsers in this case, to these machines. And in case of an online application, we need a so-called level 7 load balancer. As we have here a stateful application, this means that subsequent requests of the same user need to end up at the same machine, as these online applications are not distributing the storage currently. And therefore, as long as the session resides, you are connected by the load balancer to the same machine. This is called a sticky session mechanism. And then you can scale this environment. So if you have a big workload of thousands of users and you want to operate them on these environments, you can have multiple virtual machines, more or less as much as you want to operate with this infrastructure on the back end for scalability, but also for high availability reasons. If there is a machine that goes down Yeah, it could go down for a hardware failure, but it could also go down for a maintenance reason, so that you have to patch everything, but you can still continue with your business. And then we have the services part that we now see on the right-hand side, where we have these virtual machines that can be set up in the same approach. They expose APIs based on NTIX via the load balancer. And then we have multiple components, applications from outside, mobile devices that can access them. And here, usually a level 4 load balancer is sufficient because there's no stickiness. We have mostly stateless requests here, and they can be routed to any of these instances for each request. And we can also scale this very nicely, have multiple environments, and operate this in the scene architecture. And this applies to the advanced distributed architecture. And what is also important to mention here for our customers, if they are operating on these environments distributed, also the Adabas databases do not require to stay on the same machine. You can have for different applications, different databases, and they can be distributed to different machines to take the full advantage of the hardware capabilities of these machines dedicated to each other. So this is the advanced distributed architecture for Adabas Natural, where we will look more deeply today, and also in regard to the cloud. And what is also important is the topic about security and encryption, because today these requirements are simply coming up, and we can make sure that the data, the sensitive data, is protected on all stages. And here, looking at the same architecture, we can make sure that there is an SSL communication, for instance, reaching the load balancer, coming from outside from the browser, and there is a SSL communication completely through the load balancer until reaching the applications in the virtual machine. But not only this side can be encrypted, you can also encrypt the communication through Adabas, as we have on this page, a remote communication based on TCP/IP communication. Here we are offering for Adabas in the recent version the ability to encrypt this direct communication, this enhanced Adabas TCP direct communication as well. And finally, you have the ability to encrypt your storage, your data, and here you can rely on capabilities of the storage area network. But even if you don't want to use the storage area network capabilities, Adabas will support encryption with the upcoming release in October, so that you can, even from an applicational perspective from Adabas, encrypt this information. And this all gets important, as now we will look into how these architectures are also lifted and shifted to the cloud, this advanced architecture. And now I take you back to the slide that we saw the last time, but to raise the understanding how we are bringing these applications without architectural changes into the cloud. And this is what is simply the fastest way to move your application. So we see here the single instance architecture as a starting point with its component. It has the applications in the virtual machine, we have the storage area network, and we have the cloud on the right-hand side. It can be Azure, it can be AWS, and we can move this application into the cloud. And this means that the infrastructure components are changing. The virtual machines are now operated by EC2 instance or Azure VMs, as we could see in the last session of this webinar as well, in availability zones. And we need to bring the storage that is on the storage area network also into the cloud and move these volumes into the corresponding storage solution that we have inside of the cloud vendors. However, your application can, your architecture of your application can stay as it is. If it is a single instance architecture, you can leave it and just move the same concept, the same application architecture into the cloud. And if we now look into it in a distributed approach, we will see now the picture how it looks if you leverage this infrastructure as a service. And what do you get if you move this architecture into the cloud? And we see at the back end the storage solution. So the storage will come out of the provisioning from this hypervisor from AWS or Azure. It can be elastic block storage or a managed disk. And our virtual machines will run on hypervisors that are coming from the cloud vendors. And everything that has now this fancy color Yeah, this is coming from the hypervisors as an infrastructure service that you can operate. Yeah, so you have the virtual machines that we saw before running in the cloud. We have the load balancer as an infrastructure component. We have the users that are not probably coming from the cloud, but these are your users. And the load balancer configuration, the scaling of all these hypervisors, and this applies to exactly the same architecture that you saw in the previous slide where I drilled down this architecture, and now we see how all of these components, these infrastructure resources can now be provisioned as a service out of the hypervisors. And this is why we are getting, so exchanging all these infrastructure components and operating them in the cloud. And now we will look into each of the cloud vendors more in detail, so to get an understanding how it looks inside the different cloud providers. And today I will start with Microsoft Azure. And let's first talk how it looks into Azure before we come into demo of these components. So we saw this also the last time, just quickly as a recap. So how is the network created inside Azure? We have these regions that are local and contain a lot of data centers, multiple data centers, and they are availability zones that are distributed. And inside of these availability zones, you have one or more independent data centers that are operating your workload. And then there is a virtual network, your logically isolated section of the cloud, and subnets that are spawning across these availability zones where you are operating your network components. And as mentioned the last time, it's important to understand that customers have their own customer network, and that this customer network can access the virtual network in the Azure cloud via a gateway through the internet, but most usually companies are setting up a VPN connection and a tunnel, a redundant one, between their local network and their resources provisioned inside of the cloud. And if we look now at the architecture, how this looks like if we lift and shift these components into the Azure cloud, then we see that the picture applies that we have here. So Adabas Natural is running on different machines, different VMs, and they are distributed. They can also be distributed across multiple availability zones to run them. And they are exposing their green screen user interface through this web browser-based terminal emulation, app links. It could also be SSH, but in the web, it's simply state-of-the-art to communicate user interfaces via HTTP, and this simply makes the perfect match here. And then we have the NTX technology for service enablement and everything sitting behind the load balancer. And for the storage side, we have the managed disk storage for operating system, and then the customer, depending on the VMs and the accessibility, can decide if they need a managed disk or if there is probably a more advanced enterprise storage like Azure NetApp files appropriate to run their volumes for the data. And as said the last time, the important thing here is simply the choosing of the right Azure services. So this means the Azure VM instance type that you require to operate your workload that matches so that your compute power is sufficient that you have here, the selection of the Azure storage solution on the back end for your persistence inside of the cloud, and of course the whole topic about network connectivity, how to set up the VPN, how to set up the right communication that fits, and the deployment architecture. So make a decision how to deploy your architecture in the cloud so that it serves exactly your requirements. And before we are looking into this, let's this time look a little bit more in advanced topics, and this is about the general resiliency inside of such a cloud. And I think this picture is nicely illustrating the different levels of resiliency, starting with a single VM that is simply the easiest lift and shift approach, where you get a specific SLA from the cloud vendors. And then you see if you need more high availability for these machines, it is moving slightly into high availability, having availability sets, but they are still operating in the same data centers, and then moving to these availability zones that are still in a region, but distributed data centers across availability zones, where you have protection then from fire or disruption and flood that we see down there. And finally, the biggest thing that needs to be considered is if you have a critical application, and a lot of our customers does, you need to consider a disaster recovery even inside of the cloud, and set it up and make sure that there is a replication from your resources from one region to the other that are that far distributed that even in the case of a bigger disaster, like you said, the tornado or earthquake on, I don't know, nuclear strike probably will not be a good example, but in case of a bigger issue, you need to consider also in the cloud your setup for architecture to achieve your disaster recovery. And the other topic is about cloud monitoring. Also important to mention, all cloud vendors have their monitoring solution. In Azure, it's called Azure Monitor. And this Azure Monitor provides you with data and all these actionable insights, and you can monitor your environment, your VMs, your CPU, optimize your resources, and get this unified view on the whole operational health of your application. And this is something that we will also quickly look into the demo to see how we can see exactly these resources and the application to behave, and even the storage with its access data is reporting into this monitor. And of course, a lot of customers are using already a third-party monitoring tool. And then the question is, how can they reuse it? And of course, in general, all competitive third-party monitoring tools today provide a hybrid approach. This means you can use them for your resources in the cloud, but also for your resources on premise. And this monitoring tool can then connect to Azure Monitor to retrieve the information out of for your resources that are provisioned there. And even if it's going more into details, you can have additional monitoring agents that you run inside your VM, and then these monitoring agents can communicate with your third-party monitoring tools to give even health information that goes beyond the information that is inside of Azure Monitor. So this is a general practice, and just to give you here some understanding about cloud monitoring. So, and now let's look in the first demo for today. I will show you infrastructure as a service, and here in Azure first. And what we will see is I have a managed disk at the backend where the storage is of my Adabas data. I have a VM, an Adabas Natural VM, where Adabas is running. We will look into this, so running on a hypervisor. And then I have two VMs, Natural 1 and Natural 2, where I'm operating my online and my services components. And the AppLinks and the AppLinks user interface is having my demo application, and I will access it over the load balancer. And EntireX is having an API application that I will access via a mobile device, so that you get an understanding how exactly these infrastructure services in the cloud, how they look like and how they behave. So, and with this, let's move to my first live demo. So now let's open it. And here we are back in the Azure portal. We have seen this in the last session, and just to recap, it's an overview of all your resources that you have provisioned inside of the Azure cloud for your account. And here we have the virtual machines that we will now look into first. And you see, I have 3 VMs. These are the 3 VMs that I have provisioned. And depending on the architecture that I've described before, and the Adabas Natural VM is the first one. I will open it. We can look into some details to get the understanding. It's a Linux operating system. We have the sizing of this machine. We have the region that I'm running in Europe, zone 1. So it's availability zone 1 that we have here. And we can see some additional capabilities like our network. We have a public IP address where I could reach this machine. I have a private IP address in this machine. And we can also look a little bit into the monitoring. So here you see that this is coming out of this Azure monitor there, where we see the CPU usage of this machine, the network that is used, and also my disk access of the disks that I'm connected to. And using disk, we can also look in the disk topic today. Yeah, I showed some of these parts, so it's a little bit a recap to give you again an understanding. It helps. And we see now the disks. So I have an operating system disk on this machine with 32 gigabytes, for instance, a premium SSD. And I have a data disk, Adabas data in this case, an additional one with 64 gigabits, and it's a premium SSD. And what means encryption, you can say, for instance, here I am using this storage service encryption in this case that is coming out of the Azure offering. And it is stored in a platform management key managed by Azure in this case. So it is an encrypted environment to understand this topic as well. And what we could also look into is the disaster recovery. Always nice to show because we have mentioned this on the slides. And to give you here the corresponding topic, you remember this from the last slide, you have here the world and the data centers, and it's quite easy to set up a so-called Azure Site Recovery. And here you could select, I'm currently running in West Europe, and I could select my target region. So North Europe would be Ireland, and I'm currently in West Europe. West Europe in Azure is somewhere in the Netherlands. And you could also switch this and move it, for instance, to UK, South region, or wherever you want. You can even choose something more fancy and move it, for instance, to South Africa. Doesn't matter if this makes sense, but just to give you an impression that you can select and think about disaster recovery here and set it up easily inside of this cloud environment. So coming back to this machine, so you got the understanding of a single virtual machine, and now you see also that I have this distributed architecture. So here's my database, and in these other virtual machines, Natural 1, Natural 2, I have my natural components operating. And now, having the architecture in mind, there's a load balancer on top of these components. So let's look into the load balancer setup. So this is the load balancer, another infrastructure service, and we see here my natural online load balancer that I can open up. And such a load balancer consists of 3 components that are relevant. The first are the backend pools. So what are the machines that I have in the backend that will be distributed to? And you see I have 2 virtual machines, Natural 1, Natural 2, that are my backend in this configuration. And then I have so-called load balancing rules. And you see that I have 2 rules configured for this load balancer, and I'm distributing my HTTPS port to the corresponding natural backends, but also this entire export SSL encrypted to my corresponding backend pools. And we will see this now in use. And how do we reach such a load balancer? Let's look into the front-end IP configuration, the third part. And this is the IP address that is reachable from outside. And this IP address has a name, Natural Gateway IP. And if I now switch back to my resources here in the Azure portal, we can look into these public IP addresses. And here down we find it, the Natural Gateway IP. You see I have several IP addresses provisioned, but this is the one that is used for this load balancer. And here, instead of using IP addresses, it's simply much nicer to use a DNS name. And you see I have here a DNS name where I can use to reach that. And it says naturalsagazure.com. This is my subdomain. And now we will go into this application and access my natural application in the cloud based on this domain. So you see the chain from the IP address, the load balancer distributed to the 2 natural VMs. And now we will start this application. So I say natural SAG main minus azure.com. There you go. And now I am on my app links entry page. I can connect to this environment, and we see here natural security login screen. We are connected with this environment. You even see that we are using SSH, so it's encrypted, it is secured. I will use my user here to log in into the security environment. It's authenticating against natural security. This could be an authentication. In this case, it's in Adabas, but it could also be another service, for instance, Active Directory provisioned in the cloud. And even this Active Directory can be connected to your on-premise Active Directory so that you could authenticate with your own users that are in your enterprise. So now I'm logged into this application. We see where I landed. I am now on on my Natural 2 machine. So if you switch back, if you remember my machines, this was the name of my virtual machine number 2, and this is where I'm currently operating with this application. And this is my simple demo application. You saw it the last time. I can search for cruise inside and type in here a value to retrieve a record out of my Adabas database. So for 2010, I get the Lysistrata, and for instance, as a yacht name, we see it here, yacht name Lysistrata 2010, it's a Greece cruise, and for 750, we get the African Queen. So this is just a simple demo application. It's not about the application, but it should show you that how it looks like. If you simply take this application into the cloud, you can operate it. You can have a web emulated framework immediately by an HTTPS secured. So it's easy to bring it in there. But of course, you can also modernize your application. You can bring it easily with this front-end web. Our recommendation is to modernize this application towards something that looks even more fancy. And here I have my other application in the backend that I will show you that will now use these services that are exposed via NTIX. So, and this is my Sunny Island Cruise Information Service. It looks a little bit nicer. It's an ASP.NET demo application, and it's accessing the same microservice. So this application is running on a web server, and I will connect to my cloud environment, the one that we have seen in this architecture provision now, to retrieve exactly the same data. So on the back end, there's Adabas Natural running with NTIX, and I can also take 2010, select here Azure, say get cruises, and we get now the return of my cruise out of there. So it's again Lysistrata, and we see it's a request successful on the Azure cloud, and you can see it's an SSL communication via the service as well to NTIX through a trust store, and we are connected with this environment. And if we take 750, we are getting the African Queen. Another nice yacht from Lefkas to Hydra. I've never been to Greece, but it looks quite nice. So I will think about that. But the important thing is that we are connected via SSH. And you see how an Adabas Natural application in the cloud can be easily modernized with any user interface software the tool that you want. In my case, it was ASP.NET, and it simply fits nicely into this environment. So I think now you got the impression about these different infrastructure and what that you have as a service provision in the cloud, how they are represented in the portal, and how an application that is operated against these components can look like. And now, let's move back to the presentation and take the same into the Adabas Natural in the AWS cloud. So this is how it looked like in Azure, and now we will see how the same components look in AWS. So it's a little bit of repetition, but it helps to gain the understanding even more. So here we have, again, a look into the general setup of the network and the regions. We have here the AWS region. It has also availability zones, and it has the applications that are running inside. Here we have a virtual private cloud. This is how it's called, the logically isolated section in the AWS cloud that you are running. We also have subnets. Small difference is subnets are here bound to a specific availability zone, so they do not spawn across the availability zones in Azure. And as well, we have the customer network that is connected via VPN connection to your virtual private cloud. And this as well can be redundantly set up to make sure that even this VPN connection is available. And then we also can take our architectures that we have in premise and move them as a lift and shift approach to the AWS cloud. And then we get a similar architecture as we get in Azure. And this time it's AWS. We also have a load balancer that we are operating. We have EC2 instances, how it's called. And EC2 instances are the virtual machines inside of AWS. And here you can operate the same architecture inside and bring your VMs based from the architecture you have currently in premise. You can transfer them into EC2 instances operating in the cloud, and then have the distributed architecture as applied here. And on the back end, we have again volumes. Yeah, it's called elastic block storage that is used for operating systems, but also the product installation, for instance. And then you have several opportunities to operate your business data of the database or the natural applications. And here we have elastic block storage. We also have elastic file storage, EFS, that can be used. It can also be redistributed for multiple instances. And we can have an advanced third-party storage if you have more requirements on latency and the persistence. And here it is again, like on Azure, it's in AWS about choosing the right AWS services for your environment. And we have here the EC2 instances where you need to select the right CPU amount. We have to select the right memory so that you can operate your workload. We have the storage solution that you have to make a decision on, and we have the network connectivity. So you see, it's quite similar. Yeah? You can apply this concept to different hypervisors. We are focusing currently on those two, so AWS and Azure. And then we as Software AG can support you on making these decisions. So we have investigated on these different components, on the architecture, and you can reach out to your Software AG contact to support you, exactly make the decision on these services based on the architectures to discuss, what is the best approach for you to move into these hypervisor environments and the infrastructure as a service. And also on Amazon, we have a monitoring solution. It's called CloudWatch, to mention this here as well. And the CloudWatch is similar to what we see with Azure Monitor, for instance. It is also a monitoring and management service. It provides you also with data and actionable insights to your application, the EC2, the CPU, memory, understand your system-wide performance. And you can also set CloudWatch up to to use some alarms, to do some activities, restart instances on system failure, or visualize logs and metrics and things like this. And it is also moved everything logged into CloudWatch. And if we use the third-party tools, it applies in the same way. So state-of-the-art third-party tools are able to monitor your on-premise infrastructure, but also monitor your Amazon and also combine it with your Azure deployment so that you are able to operate here in a hybrid environment. And now let us move into the AWS cloud and see how these distributed architectures are looking inside of the AWS cloud. Also in my demo, here's the setup. So we will see an elastic block storage in this solution. We will also have an Adabas Natural VM on the back end, and using the storage on the hypervisor, we will see two VMs that I'm operating for the online and the services part, online with app links, natural services, exposed with NTIX, and then we have a load balancer, and I will access with the already fancy application that you have seen. First with the app links to my cruises in this demo, and then be distributed to one of these two environments. And then we will take a mobile application. And this was in my example, the ASP.NET that you already know. So, and now, to present you these infrastructure assets and services inside of AWS, and to get simply this understanding. Because I think if you get the understanding of these different infrastructure services, then you feel much more confident about where your components are actually, if they are in the cloud. And this whole thing gets demystified, because it is provisioned sources, resources inside of the data centers of the cloud vendors. And I think if you are here not having a great inside view about everything that you are operating, I think you don't have it anywhere. So here we are now on the AC2 management console. We saw this also in the last session. In this session, I'm not showing how easy it is to provision the different instances. We looked into this in the first webinar. So if you haven't seen that, you can recap in the first webinar. Here we are more focusing now on the different infrastructure assets so that you understand everything that exists here that is important to run Adabas and Natural in these environments. And we see here the same components that I already mentioned. We have instances, we have volumes, the storages, we have IP addresses, we have snapshots that we've created of our disk, we have load balancers and security groups that define our access. And we will here also look into them. So let's have a look in the running instances. I here have 3 running instances that are defined, and they should look familiar to you. It's the same architecture that I have set up. So I have my Adabas Natural VM on the back end that is running my Adabas database. We also have some characteristics about this environment. We have the IP addresses that we are running. We have the availability zone. In this case, it's EU Central 1A, where I'm operating it. And we have a Red Hat Enterprise Linux operating system inside of this environment. So this is my VM at the back end, and then I have my VMs here in the front end, Natural 1 and Natural 2, that are distributed. We see in different availability zones, different instance types in case of the compute power that they have. And then we can look into the volumes. Volumes are the storages, for instance, that are used for this machine. So if I move here to the volumes, we see different volumes that are created and used for these machines, as we see here, for instance, the operating system volumes that are attached. And this would be disks. If you take this from your on-premise environment on Linux, on your SAN, you also have disks that are attached to your virtual machines, and you can transfer them into disks that are represented then here as volumes inside of this cloud environment. And beside of these instances and the storage that we looked into, the elastic block storage with its capabilities, we now can have a look into the load balancer. So that's the other topic that we saw on top of the hypervisor in my architecture. And here I have a natural load balancer that we can look into. And this is here my natural load balancer that I'm accessing. And he is also configured. We can look into the description. The first page is explaining me the port configuration. So you see, I have a port, the HTTPS port that I have mapped to my backend HTTPS port that I'm running. I have here session stickiness. As you remember, I mentioned that for the online activity, you have to reach the same server with a subsequent request because the session is currently stored on this machine. And this is the SSL communication to communicate for the entire X API communication. Here, stickiness is not required. And if you look at the instances, we again see the distribution to my 2 machines in the different availability zones. The status is in service. So they are operating well, and I can create health checks to access them. And now I could reach this load balancer via this name over here, but I have also created in this AWS environment a nice DNS name. So I'm switching to a service that's called root. What was the name of it? Root, the wrong number, 53. So it's root 53. And here I have hosted zones. And I like to use these smaller DNS names instead of the long ones. So we have here SAG, AWS, to give you simply an impression of how the whole journey is. So how do I reach now my application in the cloud? You see here this is the DNS name, and then I can take this DNS name and map it to my load balancer at the back end. And here I have really a high available service available on these different nodes that are distributed across the availability zone. And now we can open this environment. So I will take now natural at SAG, natural SAG, and this time it's AWS and not Azure. So here I have a login screen on WebLink on and let me type in my username, and now we are back in the same nice natural application. This time it's running in AWS, same application. We ended up in this time on the natural 1 host. So if you look into the services here back in my EC2 instances, looking at these instance machines. So I'm now connected via app links to this natural 1 machine. This is where I ended up via my load balancer in this distribution. And I'm here on this machine in the application. The interface is emulated via HTML emulation to my user. And this can be applied to every natural application running in these environments. And here, if I'm moving into this application, I can again retrieve my records. Yeah? So you see it's again for 2010 Lysistrata, yeah, the cruise from Samos to Naxos that I can get. And in this case, also to raise the understanding, there is a TCP/IP communication from this Natural One VM with Adabas. And here we have, for those who don't know, a native TCP/IP communication that Adabas enables, and the direct communication for point-to-point that is really made to serve heavy load of users to access this application, this Adabas on the backend. And also for AWS, I'm using here a certificate that is green. So we have SSL communication with this environment to make sure that this data and everything that is transferred from my environment via the internet to the cloud, yeah, cannot be decrypted or looked into. Yeah. And because this is simply a requirement, security and encryption, and we can see how this is reflected in all these cloud environments based on the products. And if we search for another component here, we get the African Queen. So to see that this works, same behavior. And as we have this application, as I mentioned it in the other side, I simply encourage customers who haven't already to think about modernization based on services. Yeah, Adabas Natural Applications can simply be created as a backend application, and then you can choose any programming language you like to create a modern web application. And this is my simply implemented demo application based on ASP.NET again. And here I will now switch to in the AWS cloud, take the 2010, and we see it works. Yeah, so I got the Lysistrata now back for 2010. Yeah, it's a nice ship. Yeah, I hope one day I can travel with this ship over the Greece Sea. Yeah, we'll see. And this is now AWS access, and we have here also a connection now over this link using on SSL communication to communicate with this environment. So this is to give you an impression on both sides, to give you an impression how it looks like, how infrastructure as a service is now missing even the words. Yeah, so how it behaves. And to demystify, as I say a couple of times, these cloud environments and to operate in, for you to feel confident and understand when you see those architectures, where actually your application is when it's at one of these cloud vendors. And I hope this is helping you to gain this understanding. And having said this, I am moving to my last slide of this presentation as the key takeaways for this session. So I hope at the end you will remember that if you are having as a company a cloud strategy and thinking about that, moving workload there, Adabas Natural can be part of the journey. And if you want to move workload to the cloud, we can support you with the right architecture. You have seen in the first session of these webinars, we looked into a single instance architecture where it's easy to move it one-to-one with this approach. And today I've shown you more advanced architectures that can solve customer requirements on availability, requirements on scalability if you have bigger installations. And you can get all these services that you require really easy out of the cloud providers as a service, things like the load balancing, the storage, your DNS access, your virtual machines. If you look at this compared to you have to provision a load balancer in your own on-premise data center, I'm pretty sure it is by far easier to configure it to your requirements inside of the cloud. And we can help you with that. Feel free to reach out to your software AG contacts. However, we have so far just looked into virtualization technology, and there is even more. There's more about cloud native. There's more benefits, more advantages about operating in containers, operating in Kubernetes, and to understand what this is about, there are the additional webinars where I want to encourage you to register for them. That will continue in the next 2 weeks, and looking forward for everybody. And with that, I thank for your attendance today. I hope it was interesting, and I will pass over to Will at this stage for the question and answer session.
Thank you, Zvonimir. Okay, we had a couple of questions come in, so let us get into it. Can you please confirm that NetApp is a requirement for Azure, but optional for AWS?
So I would not say that NetApp is a requirement for any of the cloud vendors, but NetApp can be a storage solution that will serve your needs if you have bigger requirements to especially latency and also the whole throughput IOPS topic. So if you have a high frequent database, it can absolutely make sense, or it will probably be necessary to use NetApp. But in both cloud vendors, if your database writing performance is not extremely high, you can probably go with managed disks or the elastic block storage. Yeah.
Okay, the next question I have for you. Today we are running Adabas and Natural on Unix. Is it possible to lift and shift it to the cloud?
Okay, so it is possible in general. However, as we saw in the last session, I have not showed it today, there is no Unix operating system available in the cloud. So it's Linux, and if customers are running on a Unix today, they need some kind of a re-hosting project to bring the application on Linux. This is in general a very well-established process. We have done tons of projects moving this workload. And for Adabas Natural, this is seamless. It's more or less easy. However, some customer environments on Unix can have an ecosystem that can increase the effort. But as I said, if customers want to move to this environment, it is possible. It is even a lift and shift, and the architecture can be adopted to move into this environment. And it can especially make sense for customers that are currently on Unix, that are standing in front of purchasing new hardware, new proprietary hardware on premise. I think it makes absolutely sense to think about, instead of buying new hardware, moving to cheap commodity hardware on the cloud vendors and combine this process of moving to the cloud at this stage. Okay.
Okay, perfect. Thanks, Zvonimir. We do want to thank everybody who obviously has joined us this morning, this afternoon. We do invite you to stay abreast of all of the Adabas and Natural themed webcasts that we are planning, as was mentioned, certainly as well as all of Software AG's digital programming coming down the pike. You can do that by visiting the events section under the About Software AG tab at softwareag.com. So with that, Zvonimir, thank you for a very informative presentation today. To all of our guests, thank you for taking the time from your schedule to be with us. Our program has now ended. Enjoy the rest of your day.
Thanks. Bye, everyone.